That said, whether this specific mechanism played a direct role in this specific eruption hasn't been confirmed by in situ MH or by any independent published study, and that needs to be said plainly rather than assumed. Fuego was already running hot through 2026 before the July earthquake happened, with sustained explosive activity recorded in April, May, and June, months before the quake, at explosion rates and plume heights not far off from its long-term baseline. Volcanoes like this build pressure on their own into side trigger to blow. The earthquake may have contributed to the timing of this eruption. The timing may simply be coincidence, or the truth may sit somewhere in between those two explanations. Anyone claiming certainty on that point without pointing to an actual study of this specific event is guessing, and it's fair to be skeptical of confident claims either way until in situ MH or independent researchers publish an analysis. What is on the historical record, and this part is solid, Fuego's most destructive eruption in modern history in June 2018 came roughly 9 months after a magnitude 8.2 earthquake struck the same general region in September 2017. At the time, that 8.2 was the strongest earthquake recorded in that part of the world in modern seismic history. So there is at least one clearly documented case of a major regional earthquake preceding a major Fuego eruption by several months. That's a pattern worth watching, and worth researchers studying further. It is not, on its own, proof of a fixed cause and effect law, and treating it as one would be getting ahead of the actual science. Beyond the immediate danger zone on the volcano's flanks, the biggest day-to-day problem for most people in the region right now is ash. The plume has been drifting west, southwest, and northwest, with satellite imagery from geostationary weather satellites showing it spreading over a wide area beyond the volcano itself, and forecasts suggesting continued emissions are likely given the current activity level. Ashfall isn't just a visual nuisance, it's fine. Abrasive volcanic glass and rock particulate, and it causes real practical problems. It clogs car and machinery air filters, sometimes badly enough to stall engines. It can collapse roofing if it builds up heavy, especially once it gets wet and adds weight. It contaminates open water supplies and coats crops, threatening the region's agriculture. And it causes real respiratory problems when inhaled, especially for anyone with asthma or COPD, and especially for children and older adults, whose lungs are more vulnerable to fine particulate matter. Advisory Center has also issued advisories for this eruption, because volcanic ash is a serious hazard to aircraft, capable of damaging jet engines mid-flight by melting inside the turbine and re-solidifying on internal components. Airlines flying routes near Guatemala are watching this closely and rerouting flight paths where necessary to avoid the ash cloud entirely. So, what happens next? Guatemala's Institute of Volcanology has said outright this eruption could move into a more explosive phase, and that statement is driving the response right now more than anything else. Based on how Fuego and volcanoes boo like it have behaved historically, here's what that could realistically look like. More pyroclastic flows, already happening down the southeastern flank, possibly traveling farther, or opening new paths toward inhabited areas if the eruption keeps intensifying. Lahars, which are one of the most dangerous secondary hazards in this specific situation, fast-moving slurries of ash, rock, and water that move almost like wet concrete down river valleys and ravines, commonly triggered by heavy rain falling on fresh volcanic debris deposits. That's exactly what made the 2018 disaster worse than the initial eruption alone, heavy rainfall afterward. Try Gerd a lahar that buried structures already damaged by the pyroclastic flows. And this region is currently in its rainy season, which raises that same risk again right now. At the far outer edge of what's physically possible for a stratovolcano built like Fuego, there's the possibility of a larger flank collapse, similar in kind to what happened at Mount St. Helens in 1980. To be clear, nobody, including Guatemalan authorities, is currently forecasting that outcome for Fuego. It's mentioned only to show what this general class of volcano is capable of at its absolute extreme over a long enough timeline, not because there's any current evidence pointing toward it happening now. And finally, continued ash emissions over a wider area, which would keep disrupting air travel, farming, and daily life well beyond the immediate evacuation zone, even if the eruption doesn't escalate further. None of that is guaranteed, and it's worth saying clearly that de-escalation is just as plausible an outcome as escalation. Fuego has a long history of intense bursts that flare hard for a day or two and then taper back down into its normal, near-constant low-level activity. That exact pattern played out multiple times earlier in 2026, including sustained explosive activity in April, May, and June that never came close to escalating to anything on the scale of 2018. It's entirely possible this eruption follows that same familiar pattern. ANSYS, alms down over the coming days. The reason the orange alert exists in the first place is that officials genuinely can't know in advance which way it's going to go, so they prepare for the worst outcome while hoping for the better one. And that's a reasonable, standard approach to volcanic risk management anywhere in the world. The communities most immediately exposed are the ones sitting along Fuego's ravines and flanks, particularly the southern and western sides, which the Institute of Volcanology specifically flagged as facing the greatest risk from hot volcanic debris flows. El Porvenir and Las Lajitas were evacuated first, as the closest communities to Faimua directly in the path of the initial pyroclastic flows. Depending on how this develops over the coming days, more communities in Escuintla Department and potentially neighboring departments could be added to the evacuation list. Beyond the direct evacuation zones, the PO population affected by ashfall and air quality issues is significantly larger, likely reaching into the hundreds of thousands once you factor in Greater Guatemala City and Antigua, both of which sit within range of ash drift, depending on which way the wind is blowing on any given day. Tourists are part of this picture too, and it's worth mentioning specifically. Antigua is one of the most visited cities in Central America, known for its colonial architecture and its proximity to multiple volcanoes. Hiking up the neighboring volcano, Acatenango, specifically to camp overnight and watch Fuego erupt from a safe distance, is a well-known and popular tourist activity, drawing hikers from around the world. Hikers on Acatenango have already filmed close-up footage of this eruption over the past 2 days. Anyone with travel plans to this region right now should be hacking Conrad's official channels and current road closures before heading out, rather than relying on a dramatic video caption circulating on social media, which may not reflect current conditions or official guidance. Here's what authorities are actually asking people to do in practical terms. Follow evacuation orders the moment they're issued, and self-evacuate without waiting for further instructions if conditions turn dangerous where you are. Stay away from river valleys and ravines near the volcano entirely, especially during and immediately after rainfall, because of the lahar risk described earlier. Wear a mask or cover your nose and mouth if you're in an area experiencing ashfall, and keep windows and doors closed where possible. Keep vehicle and machinery. Air filters clear of ash buildup to prevent mechanical damage. And follow Conrad and InSivuMe directly for real-time, verified information, because raw footage circulating online is often genuinely accurate as footage, but the predictions and claims attached to that footage in captions and comments frequently are not. The story here has never depended on the mountain doing something dramatic this particular year. It's that roughly 90,000 people live where a lahar could reach them, and on the least likely path of that happening, there would be almost no time to react. Let's get that number exactless. I write, because this is where misinformation online gets its worst. USGS's current figure from May 2024 is that more than 90,000 people live in areas that could be affected by a future large lahar. The number you'll see quoted most often online instead is 2.5 million. That number should not be used the way it usually is. It comes from a Washington State Department of Natural Resources circular, and the actual sentence behind it says Rainier's 11 rivers lead to 6 lowland valleys, with a combined population of more than 2.5 million people. That's the total population of 6 entire valley systems, a broad regional total. It is not the number of people sitting inside an actual lahar hazard zone, and presenting it that way is simply inaccurate. 90,000 is the real current figure, and it's serious enough on its own without inflating it. Underneath that 90,000 figure sits 63 schools, 30 child daycare facilities, 19 adult residential care facilities, Interstate 5, and the Port of Tacoma. Pierce County's own hazard assessment states that a lahar has the potential to cause the highest number of fatalities and casualties of any hazard they evaluate for the entire county, ahead of floods, ahead of earthquakes, ahead of everything else on their list. In their words, most of Puyallup, almost all of Sumner, and all of Orting could be totally destroyed. Which raises the only question that actually matters here. How much warning would those people get? It's worth understanding why this particular set of towns ended up sitting in the path in the first place, because it wasn't an accident of bad luck so much as a slow accumulation of ordinary decisions made over more than a century. The Puyallup Vai. Leh has some of the most productive farmland in the Pacific Northwest, built on exactly the kind of flat, fertile soil that a lahar deposit leaves behind once it settles and weathers over centuries. People settled there for the soil long before anyone had the geological tools to recognize that the soil itself was the fingerprint of a past disaster. Railroads followed the flattest, easiest grades through the valley. Towns grew up around the railroads, and population kept building on top of population for generations, all without anyone connecting the dots between the ground they were standing on and the volcano visible on the horizon above them. It wasn't until the late 20th century, once hydrothermal alteration and lahar dynamics were properly understood by geologists, that USGS and Pierce County could finally look at the valley floor and say plainly, this entire landscape was built by the same kind of event we now need to plan for happening again. There is a detection system, and it went operational back in 1998, built on 1990s equipment. Buried acoustic flow monitors and tripwires running on low bandwidth and low power, meaning data was only transmitted every 2 minutes. Engineers who later reviewed and upgraded the system described the result as at least 4 minutes of delay between a lahar actually peaked up, passing a sensor, and the system reporting that a lahar had passed it. 4 minutes lost out of the roughly 60 a flow takes to reach Ording. That system is being upgraded right now. 14 new monitoring sites went in between 2017 and 2021, with up to 20 more planned, heading toward more than 40 real-time stations total. USGS attaches one important caveat to all of it. They mean it seriously. This system reduces, but does not eliminate, risk in the lahar pathways. Here's the real timeline in practice, and this is the number that sticks with people once they hear it. According to USGS, if a large lahar were generated in the upper Puyallup River Valley, without the precursors that typically signal volcanic unrest, meaning exactly the no-notice scenario this whole story is about, it could arrive at the city of Ore. Ting, as little as 40 minutes after the initial warning is sounded. 40 minutes after the warning sounds, not after the lahar itself starts moving. Total time from the mountain letting go to the flow reaching Ording is roughly an hour, and detection and notification eat up the first 20 minutes of that hour before anyone EVN hears a siren. Sumner sits at about 2 hours, Puyallup at 3, Auburn at 5. Higher up the mountain, it's far worse, roughly 10 minutes to reach the Nisqually Park entrance. Notice the actual speed involved here because it matters. USGS's 2021 modeling puts the flow front at roughly 4 meters per second by the time it reaches Ording, which works out to about 9 miles an hour, not the 45 to 50 miles per hour figure mentioned earlier. That higher number applies close to the volcano, inside the tight, confined valleys near the summit. Attaching that speed to Ording would be flatly wrong, and it's a mistake that's been made before. Here's a correction that actually cuts against the scary version of the story rather than adding to it. In that same USGS simulation, after passing through the Ording lowlands, the lahar slows down and comes to rest in the valleys around Sumner and Puyallup. The worst case, no-notice lahar in USGS's own physics model does not reach Puget Sound. It does not flood Tacoma. The scenarios that do reach the sound are the eruption-driven Osceola-class events, and those operate on a completely different scale and a completely different timeline than a no-notice lahar. Even the deadliest realistic version of the no-warning scenario has a physical limit to how far it travels, and that limit matters just as much as the danger itself. 40 minutes of real evacuation time is not nothing, but it's also not enough, and Pierce County says so directly. Having a warning system in place does not mean everyone will be able to evacuate the valley bottoms in time. In the upper valley, our own assessment states there could still be many fatalities, and for first responders trying to reach Ording during an active event, their assessment is that doing so will be out of the question, which is exactly why the current USGS brochure carries an instruction in bold worth reading twice. Be prepared to evacuate on foot, not by car. Roads can quickly become clogged during a sudden evacuation. That instruction is the reason school kids in 5 districts south of Seattle walk uphill away from the mountain every spring, and it's also the reason for something happening in Ording right now that's genuinely remarkable. Ording sits in a bend of the valley with the river running between the town and the high ground. So the town is building a bridge, but not for cars. A pedestrian evacuation bridge over State Route 162, running from the Foothills Trail toward Rocky Ridge. It does 2 jobs at once, a walking route for school children on an ordinary day, and an escape route on the worst day possible. Phase 1 cost only $9 million in state funding. Construction started in early 2025, and the city has targeted this summer for completion. A second bridge is planned over the Carbon River, heading up toward Tahale. You'll see a $40 million figure attached to this project in some places online, but that number belongs to a much larger suspension bridge concept from 2016 that was never actually built. What's actually under construction is the $9 million structure. A town spent $9 million on a footbridge because the mountain might not give anyone enough time to drive out. Now, let's close the loop on Yellowstone properly, because the comparison in this video's title deserves a real answer, not a cheap one. USGS puts the yearly odds of another caldera-forming eruption at Yellowstone at roughly 1 in 730,000, and they state plainly there's no evidence one is coming within the next several centuries. Don't let anyone tell you Yellowstone is overdue. That claim comes from taking 3 historical eruptions, measuring the 2 gaps by between them, averaging that gap, and then treating the result like a bus timetable, which isn't how volcanic recurrence actually works. To be fair to Yellowstone here too, because overcorrecting is its own kind of distortion, Yellowstone is not rated a low threat. In the 2018 assessment, it landed in the high threat tier, the second of 5 tiers overall, which is a serious ranking on its own. Rainier simply ranks above it. Now put Rainier next to that number. USGS estimates large lahars reach the Puget Sound lowlands at least once every 500 to 1,000 years, which they translate into roughly a 1 in 10 chance within an average human lifetime. You'll see a 1 in 7 figure floating around online for this instead. USGS stat. As 1 in 10 across 2 separate publications, so that's the number to go with. 1 in 730,000 per year for the Yellowstone scenario everyone fears. Roughly 1 in 10 per lifetime for the Rainier scenario almost nobody has heard of. That's the actual comparison, and it didn't require exaggerating a single number to make. USGS says something else that lands harder than any ranking. Mount Rainier has erupted less often and less explosively in recent millennia than Mount St. Helens, but the proximity of large population centers and valleys susceptible to ours makes it a far greater threat to life and property. A mountain less violent than the one that exploded on live television in 1980, made more dangerous purely by who moved into the valleys below it since. That's the entire case for calling Rainier America's deadliest volcanic threat without needing a single eruption to justify it. And if you want to know what it looks like when the warning doesn't arrive in time, there's a case USGS itself uses directly. And it's the reason this story needed to be told. On November 13th, 1985, a lahar from Nevado del Ruiz in Colombia reached the town of Armero and killed more than 23,000 people. Pierce County notes that flow was small compared to some that have come down from Mount Rainier in the past. Mud depths of 6 to 16 feet, roughly 6.5 feet of flow, wing concrete on average, and 23,000 people dead. USGS captions a photograph of that town with a single line. Tragically, safety lay nearby in areas of higher ground. That disaster happened because the warning that did exist didn't reach the people who needed it in time. That's the exact failure mode Washington State is trying to design out of its own system right now before it has to be learned the same way. Here's the practical part, kept short and real, because information without a next step just turns into anxiety, and that's not the goal here. If you live in the Puyallup, Carbon, or Nisqually valleys, the most useful thing you can do this week takes about 20 minutes. Find out whether your address sits inside a lahar hazard zone pier. See County and Washington State both publish the maps publicly. Then find your evacuation route on foot. Walk it once and time it, not drive it, walk it. If you have kids in one of those 5 school districts, they've probably already walked their route, and they might know it better than you do, so ask them. Learn what the sirens actually sound like, and decide right now that you'll move on the first one you hear instead of waiting for confirmation. Because in the no-notice scenario, the confirmation is the mud arriving. Agree on a meeting point on high ground with your household, and plan under the assumption that phones won't work and roads will be blocked. And if you don't live anywhere near a volcano, this lesson still applies directly to you. The gap between what the ground can do and what the people living on it have actually prepared for, that gap is where casualties come from, in any hazard, anywhere. 72 hours of water and food. D, any medication you depend on, a flashlight, a radio, a first aid kit, copies of your important documents, and one plan that everyone in the house actually knows. It's an afternoon of work, not a lifestyle change. On a clear day, Mount Rainier sits right there on the horizon from Seattle and Tacoma. It's beautiful. People photograph it constantly. About 90,000 of those same people live on ground the mountain has already covered once before, without an eruption warning it was coming. The hazard isn't. No, hidden. It's mapped. It's modeled. It's wired with sensors right now, being upgraded as we speak. And it's rehearsed every spring by kids walking uphill on an ordinary Thursday morning, because the adults around them decided practicing beats, hoping. $9 million on a footbridge. 5S. School districts running drills. A siren network being modernized station by station. That's a community that looked at a 1 in 10 lifetime probability and took it seriously without waiting for a headline to force the issue. One last comparison worth making, because it puts everything above in perspective without needing a single new statistic. Japan lives with active volcanoes across the entire country and has built one of the most sophisticated volcanic monitoring and public warning systems in the world, specifically because the alternative was proven unacceptable generations ago. Indonesia, the country that gave lahars their name, evacuates hundreds of thousands of people around Merapi and other volcanoes on a regular basis, treating evacuation drills as routine civic infrastructure rather than something reserved for a crisis. What Ording, Puyallup, and Sumner are doing right now, the drills, the sensor network, the footbridge, is the same basic playbook, applied at a smaller scale to a mountain most Americans have never thought of as dangerous at all, because it isn't smoking, it isn't rumbling, Saint sits there looking scenic on the horizon. That's precisely what makes Rainier a harder sell for preparedness than a volcano that visibly threatens people. And it's exactly why the schools, the county, and USGS keep pushing the message anyway, year after year, without an eruption to point to as justification. The mountain will do what it does on its own timescale, and nobody, including USGS, can tell you exactly when that will be. What's already decided, right now, today, is how much of that valley knows the way out, and that part was never up to the volcano. The evidence for taking Rainier seriously was never going to come from the volcano doing something dramatic on camera. It was always going to come from the ground itself, and the ground has already spoken, twice, 5,600 years apart and 500 years apart, in exactly the valleys where people now live.